So Alcatel, Lucent, long-time MySQL cluster user. They've been, again, our biggest telco customers probably push the product harder than anyone else and have, requested lots of changes. A lot of stuff you see in cluster today came from their usage of cluster and what they wanted. A few years ago, they did a bake-off between X10 and cluster and some other technologies and decided to choose cluster. They use it for home location registry, tables and databases, and for their cell phone system. So again, pretty strong usage from the telco market. If you look at the web space, again, we're starting to see people use it in e-commerce space and for profile management. But for the World Cup in 2010, a company needed to set up services and wanted to use a database that was, again, highly available and highly scalable because they didn't know what kind of traffic they would be getting against the website. So they needed to be able to scale as quickly as possible. And they've been using MySQL clusters successfully to support the World Cup services. And my last example is for document management, which is kind of a strange one and kind of a new one for us, where, again, they're storing, I think these are legal, I think this setup is for legal documents, the one customer that I know of. But what's interesting here is that they're deploying this on Amazon's EC2 service. So they're not even running it locally for them. But they're doing document management using cluster. And successfully. So it's getting more varied uses. Great database if you need 5 nines, need highly available services. So there's no other questions? Yes?
What are the schema limitations and what can you do?
So great question. So the schema limitations and what can't you do with the NDB engine? So one is the number of rows support, number of columns supported. So currently it's 128 columns, so you can't have more than 128 columns. In 7.2, that'll go to 512. In the current release, you can't have a row size bigger than 8K. Now that's for integer and varchar and character fields and date fields. You can use blobs and text objects with cluster, and that will get you past the 8K limit. One of the biggest limitations I see out in the field is there's no reference integrity support. So you can't use foreign keys. That's probably the biggest one, the biggest stopping point for everyone. And I'm pushing hard on it to add it, but it's a big problem. Yes?
Thank you. You mentioned the objects a number of times. How much is the mechanism slowed down by using objects?
By using objects in Java?
No.
Oh, I'm sorry.
In MySQL. By storing all...
Oh, the blobs?
Yeah.
I don't know a number or percentage. It does add some overhead to cluster, so there is some slowdown. It actually sets up a hidden table for storing blobs and things like that, so the access methods to get the blobs and to access them are a little more involved.
Thank you.
Yes.
Can you touch on, like in the multi-master setup, like how cluster manages the writes in a multi-master? Like how, to make sure data
Sure.
integrity and...
Yep. So his question was, in a multi-master setup, how does cluster manage the writes? So let's go back to that picture. So let's say I have, in this instance, 2 MySQL servers. And I have some type of load balancer, and I can load balance across those servers, however many I have. Whenever the MySQL server wants to insert a record or change a record or update a record, it basically contacts one of the cluster nodes. And it doesn't have to worry about which one it's going to contact. It just contacts one of the cluster nodes. If it can, cluster will try to look at the row that's being inserted and look at the primary key and make sure that it can attach to where that node is going to be stored. So there's technically there's a coordinator that gets set up on one of these data. So any node can act as a coordinator. So for one insert, it chooses a node, it acts as a coordinator, it does a 2-phase commit across 2 nodes, making sure it can write, and everything's happy. If you get a flood of requests, basically it round robins across those nodes. and allows it to set up transaction coordinators across any node within the cluster. So if I'm doing updates, if I have an insert and an update, trailing each other for the same row, it still has to wait for that insert to finish. I mean, it's going to lock it and make sure that it can't change it until it, for the update to wait until it inserts. So technically, cluster handles it all within itself.
So would you use something like the DRBD on the two MySQL instances?
In this instance, you don't.
Okay.
You don't need to. So his other question was, would I use DRBD, which is another method of making sure that the master database is highly available. In this instance, you don't need DRBD.
Okay.
Any more questions?
Yes.
Last question, promise.
You're holding them up for once, but it's all right. Just kidding. Go
In
ahead.
one of the earlier presentations, there was a slide for the ideal MySQL server.
Right.
For cluster, are there any min-maxes on memory, cores, or anything like that that we should be aware of?
That's another good question. So on cluster, from a data node perspective, you don't need more than an 8-core machine today. It's multi-threaded, but it's not going to take more than 8 cores, which is a dual socket 4-core, right, per socket machine. Memory, it's how big your database is. I mean, it can run in a 64-bit environment, so if you have a large database and have enough memory and have enough money, it can take advantage of it. So from a minimum size, it can be as small as the smallest server you can get. From a maximum size, it's on the cores. It's not going to take advantage of an 8-core, an 8 CPU, 32-core machine at a data node level, unless you want to run more than one data node on it, which is also a consideration.
Any more questions before lunch? I guess nobody will ask any questions now.
No, and I'll be around and
Yes,
for
Craig
follow-on
and
questions.
Tony and Bill and our MySQL team will be here around lunchtime.
Yes.
So if you have more questions, feel free to approach them directly. And now it's lunchtime.
All right.
Yay!
Thanks.
So we will be back.